So here we need to find the value of sine x when we know what the value of cos x is, but we have to give an exact value. I'm just going to show you that we can't just use our calculator here. So if we do inverse cos of 1/3 and then we sine that value, we get a decimal, so we don't get an exact value. Luckily, it's really straightforward to answer this question. Okay, we start by drawing a little right-angled triangle. Okay, I'm going to pick this corner to have the angle x. Okay, so cos x is 1/3. That gives us the ratio of the adjacent to the hypotenuse sides. So if I put the adjacent side as 1 and the hypotenuse side is 3, then cos of x is going to be 1/3. I could have used 1/3 and 1, I could have used 3 and 9 and so on, it would still work. Okay, but we have a right angle triangle, we know two sides, we can find the opposite side to the angle using Pythagoras. So we're going to do 3 squared, take away 1 squared, so 9 take away 1 gives us 8, and root 8 is the same as 2 root 2. Okay, right, so the to get sine we do opposite divided by hypotenuse. So we have 2 root 2 over 3. Okay, now we're told that x is acute, and so this all works fine. Let's look at tan. Tan is opposite over adjacent, so that will simply be 2 root 2 divided by 1. So that's it. Okay. Now, if we look at the second question, it's almost identical to the first, except that we're told that x is an obtuse angle. So the same information still works. So I'm going to write down from before that we had sine x is 2 root 2 over 3, and this time we've got, it says cos x, but it should say tan x. So I'll just change that. There we go. Tan x was 2 root 2. Now, how does this obtuse angle business come into play? Well, if we use a cast diagram, we can see what's going on here. So we're told that x is an obtuse angle. So if we measure from anti-clockwise from kind of the positive x-axis, we measure and this gives us positive angles. So we know that all the angles in this zone are between 90 and 180, so they're obtuse. Okay, so I'm going to just draw a little stick in there, and my angle x would go in there. Now, the use of this is that it tells us that sine is positive for obtuse angles, but none of the others are. Whereas for acute angles that we looked at last time, they were all positive, so we didn't have to worry. So here, sine is positive, so we can leave that as positive 2 root 2 over 3, but tan is negative, so we need to put minus 2 root 2. If we prefer a graph, you simply need to think about sketching the graph of sine, okay, and looking at between 90 and 180, and we can see that it's positive. And if instead we were looking at tan, then we know that 90 is here, 180 is there, and in this area tan is negative. Okay, but I think the cast diagram is faster there.